Hello, I'm Abram Champion, and this is my video for the Maclaurin series for square root of x plus 1. Alright, over here we have the general form for Maclaurin series. Basically just f's nth derivative of 0 times x to the n over n factorial. Alright, so the first thing you want to do when you're trying to figure out how to do the Maclaurin series is write down the first 4 or 5 derivatives of your function. And you see we have that here. Second thing you want to do is evaluate your function at 0. Pretty straightforward. Basically 1 plus 0 is just 1. 1 raised to any power is still 1. So you're left with your coefficient. Well, yeah. And alright, well, that's about where the easy part ends. Now we have to try to find a pattern in this. Well, the numerator for this pattern is fairly straightforward. You just have 2 to the n. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. Third power is 8. Fourth power is 6. Alright. But the numerator is kind of tricky because you have the first 3 terms have a magnitude of 1. You got 1, 1/2, 1/4. And then you also throw in the fact that it alternates once it gets down in here. Negative, positive, negative. The next one is positive, and that one after that is negative. But the first 2 terms don't alternate at all. So that's tricky. Well, let's go over here and try to evaluate the numerator. Alright. Well, I Googled a lot for this problem. It's pretty difficult. Came up with this term called the double factorial. If you plug it in, basically double factorial means you're multiplying all the odd numbers. So if you have like 5 double factorial, it's 5 times 3 times 1, you get 15, or 7 factorial, it's 7 times 5 times 3 times 1, 105 equals 105. Alright, but you can't quite put this in because let's say we have the 0th term, I have negative 3 factorial, which is like undefined, and that's weird. But if you do a little trick where you take basically you divide by the 2n minus 1, you can write it like this, because basically what you have here is first 2 terms you have something like, say, 2n minus 5, the dots. You got terms coming before that. (2n minus 3 times 2n minus 1. And then if you put 2n, there's 1 on the bottom. Basically these can like cancel out. And you have the same thing, but you wrote it different. You have the same thing, but you wrote it different. It's just a trick. And now we don't have the whole negative 3 factorial. In fact, you can, and then this can be further simplified into 2n factorial over 2 to the n power times n factorial. And when you put all of that together, remember this only takes care of this, so then you put it with multiplied by this part right here in the numerator. You're left with this. That's just the numerator though. The numerator of this part. So we're not even done. We still have to add this little thing onto it, the 2n. 2 to the n. Okay. Alright. So when we do that, what we have is this is the 2n that was from the numerator part. I mean, yeah, when we did the numerator. And that's the 2 to the n from the denominator. So we just combine them. We have 4 to the n. And you did all this just to get done with your numerator. And I gotta speed up because I'm running out of memory. This will take care of the alternating signs. We're putting it all together now. The x, remember, that's just from our general form right here. This n factorial also comes from the general form. And this, we've got to flip it so it maintains the same magnitude, but we can get this action we have right here, where this, like, the first two are positive. If you flip it, this will work out. I don't have time to do it right now because the memory's running low. But basically you end up with this.